Okay, 3, 2, 1. So it is live, and then I'm going to hit record here. Welcome everyone to the Bitcoin Olympics Hackathon. This is a Bitcoin ecosystem-wide hackathon where multiple Bitcoin communities, protocols, and champions have come together to support, reward, and celebrate the innovative spirit of founders and builders on Bitcoin to create valuable use cases for a sustainable Bitcoin economy. I'm Albert, CEO of Bitcoin Startup Lab. We brought this show to you, and we're a top pre-accelerator in the Bitcoin ecosystem, helping people turn ideas into investment-worthy startups on Bitcoin. And a big shout out to our media partners, BTC Inc., parent company of Bitcoin Magazine. They're the top media on Bitcoin and CryptoSlate, a crypto-agnostic media platform that brings the latest happenings on Bitcoin to the rest of the crypto world. And a big thank you to all our teams and all the guest speakers that have come together to make the Bitcoin Olympics Hackathon possible for you and accelerate the advent of the Bitcoin economy. And today, it's our great pleasure to invite Steve Myers up. He's a contributor of the Bitcoin Dev Kit project. And it is our hope that after you see his presentation, that more builders will come build on Bitcoin. Thank you, Steve, for coming. How are you doing?
Great. Thanks, Albert. Thanks for inviting me. And looking forward to telling more folks about Bitcoin Dev Kit and what we can do with it to build more Bitcoin projects.
Super. So the floor is yours.
Great. Thanks. I'll jump right in. So again, my name is Steve Myers. I'm one of the contributors on the Bitcoin Dev Kit project. I guess I should also mention Bitcoin Dev Kit is a open source, completely free, MIT licensed library. We also have a nonprofit foundation that helps support it called the Bitcoin Dev Kit Foundation, which I'm also the president of. So we haven't talked a lot about it yet, but you'll hear more about that in the future. So anyway, but about the Bitcoin Dev Kit, like I said, it's open source. We're on GitHub, and I can be reached at GitHub or on Damus or also on Twitter. I go by Not Mandatory there. The main website for the Bitcoin Dev Kit project is bitcoindevkit.org. That has links to everything related to the project, including documentation. So I'll just jump right in and tell you a little about what Bitcoin Dev Kit is all about. You can think of it as a easy to use toolkit for builders. It's built on a suite of core projects. Rust Bitcoin has some Rust libraries that provide like basic building blocks for making Bitcoin applications, such as what a Bitcoin block structure looks like, what transactions look like, how you sign transactions, things like that, script types, network types, all that. But what Bitcoin Dev Kit provides on top of that is sort of an easy to use API with sort of filling in all the missing glue pieces to glue all the components you might need together to provide a fully functioning Bitcoin wallet. Some of the reasons you might need something like this is if you don't want to have to basically reinvent things like signing algorithms and coin selection and how you talk to different blockchain data providers, things like that. So we wrap it all up, test it, provide documentation in one nice, convenient package. So some of the modern features that are a little hard to find in other libraries would be things like, so the whole Bitcoin Dev Kit's built on descriptors. So descriptors are a way of defining your wallet and which transactions you're going to monitor and spend. Miniscript is an additional way of defining your Bitcoin scripts that allow you to support things like time locks and hash locks within your descriptors. Descriptors themselves in BDK and Rust Bitcoin, we support all the script types. So, whether it's just a simple public key, public-private key, all the way up to Taproot. So we have full Taproot support for not just sending to Taproot addresses, but you can actually create your own Taproot addresses, have a fully Taproot capable wallet with tap script paths and everything. So, and then of course we also support all the basic key derivation tools such as hierarchical deterministic key paths and everything that's related to that. So you can have just a single seed, generate all your keys from that. And then we also support PSBTs. That's really important for interoperability with different wallets and different tools like hardware wallets or hardware signing devices. Everything our library, our toolkit provides talks PSBTs, so partially signed Bitcoin transactions. And then, for backup, so you're making a wallet, you want to be able to make it easy for users to back up their keys. We also support tools or APIs to create mnemonics and 12 to 24 words, including an optional password, if that's how you want to design your application. So those are sort of the high level features. We basically, the idea being that, we're a well-tested, built on a strong foundation. And I should mention also that within the Rust Bitcoin ecosystem, our actual cryptography libraries are the same ones, the exact same C code, in fact, that's used by Bitcoin Core. So you don't have to, you as a wallet developer don't have to worry about how, how all of the cryptographic primitives in Bitcoin work, whether it's Schnorr signatures or, any of that sort of stuff. It's all baked into the library based on the same code written in C that we wrap it up in Rust and then other languages. So you can just access it. So I wanted to talk a little bit more real quick, just because since we are a descriptor-based wallet, the way you define your wallet is by constructing this thing called a descriptor. If you're not familiar with descriptors, they are supported in Bitcoin Core and some other wallets. Most of the new wallets support descriptors. So just it's a nice way of sort of backing up a summary of everything you need to know about the wallet. So WSH in this example is the script type. So it's a witness. So it's a witness script hash script wallet. It's a sorted multi-sig, which means it takes 2 out of 2 signatures to sign. And then what we have next are the keys. So you've got first the seed derivation, the seed fingerprint, and then the derivation path, and then the public key at that derivation path. And then 0 generally means it's not a change address. And then star means that just tells the descriptor that it's not a single key. You've got a hierarchical determination. You're going to derive a bunch of keys that basically gets replaced by an index. And then we have our second key, and then we have a checksum. So all these things, all these checksums, like the fingerprints for the seeds and the checksum, they're all like safety mechanisms to make sure that if you back this up and you restore it to another wallet, there's no mistakes, and you'll get the exact same history of transactions for your wherever you backed up or restored to. So quick to sidetrack there. So back to what BDK provides to you as a application developer making a Bitcoin application. And again, I'm talking Bitcoin on-chain. BDK is focused on on-chain functionality. There is a sister project called LDK, Lightning Dev Kit, where both projects are in Rust. A Lightning Dev Kit provides a full stack, everything you need to build a Lightning wallet. I'll let the Lightning guys, the Lightning Dev Kit folks talk about that someday. But just so if you are building a project that needs both Lightning and on-chain and off-chain, there is this other project. And there's a good example of a project who used both BDK and LDK is if you've heard of the Mutiny wallet, which is using both, and it's written in Rust, running in a browser through WASM. So anyway, back to what you can get from our API. You can get all the basics. So you can get a new address from your wallet. You can list all the existing transactions and your balance of your wallet. You can create a new transaction. You can sign it. You can combine a transaction signed by one wallet via PSBTs to another wallet. Then you can then finalize that PSBT. And I didn't put it here, but you can use an API to broadcast that finalized signed PSBT out to the Bitcoin peer-to-peer network. One of the advanced features that BDK, the wallet's API, provides is what's called branch and bound coin selection. So it's a very efficient way of creating a transaction from your existing unspent Bitcoin in a way that's that's optimal in terms of the size of the transaction. It also takes into account kind of an expected future fee rate. So it takes a lot of parameters into consideration to get you a really efficient transaction, it's a good example of one of the things that would be hard if you were just building your own library to reproduce. And then we also provide manual coin selection. So if you want to give users the ability to select exactly which pieces of Bitcoin they want to spend, we allow them to do that. So you can kind of combine the automatic coin selection with manual coin selection, manual coin control. It's very good for privacy. It's also good if you're worried about things like maybe there was dust thrown into your wallet. You can just exclude those dust pieces of Bitcoin, which they can cause you privacy issues. They can also make your transactions bigger than they need to be. And then we also do other things like fee control. So you can set either a fee rate or an absolute fee amount. And we support creating transactions that can be replaced by fees. So an interesting application there is making a wallet that maybe starts out with a low fee rate and then automatically bumps the fee up if needed. We support those kind of features. We also support either single or multiple recipients. So if you're building a larger, say you're an exchange or something, and you want to batch your payments, we support that. So you can send it to a single person, or you can make one transaction that goes to multiple recipients. And then people don't talk about it a lot, but there is this thing in Bitcoin called op return, which allows you to put a small bit of sort of arbitrary data into your transaction. A lot of people do that today with Taproot. They put it in the witness script, but there is also a way to do it without Taproot using op return, and we support that. It's used in applications today, like things like a timestamping service. There's a system called Open Timestamps. They use op returns to timestamp arbitrary data. All right, so just a quick mention about multi-platform. So even though this library is written in Rust, that's its native code, and that means by being in Rust, it can run on any platform that Rust supports, including WASM. So there's a kind of a virtual machine in everybody's browsers that will run this binary bytecode called WASM, and Rust supports compiling to that target. We support that also. But in addition to that, specifically, we wanted to make it easy for people that are building mobile apps. So that would be Android or iOS. So we provide a whole nother sort of a side project that builds the Rust code and then wraps it up and packages it for Kotlin or for Swift. The Kotlin packaging supports, of course, Android, all the platforms for Android, Linux or Mac OS. And then the Swift packaging supports all the Mac platforms, so iOS, Mac OS, tablets, phones, whatever you want to do. And then we also support Python's a really popular language for just experimenting and also for making examples and tests. So we also support Python either for Linux, Mac OS, or Windows. There's also, you could actually build a whole application on Python if you want. And the nice thing is, since they're all built from the same Rust code, they all have the same feature set. So whatever you can do in Python, you can do it in Swift or Kotlin or just in Rust. So it's a nice way to just take all of that very complicated business logic of making Bitcoin wallet features and just extract that out and have it be the same on all these different platforms. All right, so, and one final thing about features. So we have sort of a pluggable design for the blockchain client. So a blockchain client is where you get your blockchain data from. The options we support on all of the platforms are Electrum and Explora. If you're building something on a server or something on a Rust-based platform, we also support RPC. So that would be to talk to a Bitcoin core node. But for mobile apps especially, it's really common to use Electrum or Explore, which are sort of more lightweight network protocols. And then for those protocols, we also support, one of the downsides is they're not very private, but we do support an optional SOCKS 5 proxy. So SOCKS 5 proxy is something you could use as if you were running the Tor, like a Tor proxy on your phone or on your computer. You can plug in our client code to talk to that proxy. So you can still get some pretty good privacy that way. And then the same thing for data storage. So the wallet has its own internal data for things like transaction data. And we allow you on the phone, most people use SQLite. You can also, if you're making an application that doesn't really need to persist that data from run to run, you can just store it in a memory database. And then if you're using Rust, you can basically use whatever database you want. We give you just an interface that needs to be implemented, and we have some users using Postgres on more of a bigger server application, or whatever other database you like. You can easily integrate it that way. Okay, so I'm doing on time here. Some project ideas. So this is, I think, this is a hackathon. This is kind of giving you some ideas. There's sort of different categories, since it's basically anything you want to do with an on-chain wallet, on-chain Bitcoin, is a great fit for a BDK. Some ideas might be if you're like doing something exchange-like you're doing something that might have to do with an exchange. A lot of exchanges need mobile apps, like they might have a server with an API for doing trading, but they don't have a mobile app. So this gives you the ability to make a non-custodial mobile app where, say, you buy your Bitcoin, instead of getting it deposited into a cold wallet at the exchange, it can literally just send it right to the user. So the user gets it on their phone in their non-custodial app. I think that's something I'd love to see more of. Another one might be, so if you're an exchange, or you might be just, it comes up with exchanges, or maybe you could even be a business that's like a payroll business or something like that, and you just need to do batching. So we have a user right now called Galoy, which they make a sort of a community wallet where it's custodial. It's a custodial community wallet, and they're building a service using BDK for batching transactions. So when they make, say every 10 minutes, or I don't know what their time frame is, but they send out payments from their system to their users, they batch them up. One common reason for this is that why you wouldn't necessarily do it. So like, say you're using LND or a system like that, you're using the on-chain wallet, like you're doing a Lightning application, but you may not want to use the Lightning library as your on-chain, because often they don't have some of these more advanced features like batching or replace by fee, things like that. So a batching service for a kind of a large custodial system would make sense too. Another one that I have not seen anybody do, but I think it would be a really interesting one, especially now that we're in a higher fee environment, would be like an auto RBF service. So that would be something where, so RBF means replaced by fee. That means you can take an existing transactions that's sitting in the mempool and not getting confirmed, and then bump its fee up. So basically take it, add an additional fee input, or potentially you could even do it as a child pays for parent, where you make a new transaction that spends that child transaction and effectively also bumps the fee. And you could do that as sort of a service. Like somebody could say to you, "Hey, I've got this transaction. It's stuck in the mempool. You could go to this service's website and say, here, I'm going to give you a little Lightning payment, and then you're going to bump my on-chain for me," something like that. But basically, sort of a way of helping people confirm transactions, get them confirmed sooner. So those are sort of some more centralized, potentially custodial systems, or mix of custodial and non-custodial mobile would be interesting. The other one would be privacy-focused stuff. So what's nice about having a open source, mobile-friendly on-chain library is that you can now do some things that you could only do with a real custodial kind of library, which would be like coin control. So just what I mentioned before, where you can, say you bought some Bitcoin from an exchange, and then you bought some Bitcoin person to person, and then you might have gotten some for working. You might want to not mix your basically non-KYC Bitcoin with your exchange purchased KYC Bitcoin. So adding a wallet that makes it easy to say tag where your Bitcoin came from, and then you say, okay, if I'm spending back to an exchange, I can go ahead and spend my exchange Bitcoin. But if I'm, paying for something, paying for something somewhere that I don't want to mix with my KYC information. I'll give you coin control, so you can just pick and choose which ones to spend, and group them in a certain way. Another one might be Taproot. So Taproot's nice because it allows you to have multiple spending paths. So you might say, I'm going to spend with a single key by default, or maybe a single key with, or maybe multiple keys as default. But if I don't have access to one of my keys, I'm going to use a different spending path, or I might use a key plus a timeout, or potentially I'll use, Alice and Bob key. And then if Bob's not available, I'll use, Alice and Carol's key. But all of those spending options are actually hidden if you don't use them using Taproot. So with SegWit Bitcoin, you have to kind of expose all of the different options, but with Taproot you don't. And that's a nice privacy feature with Taproot, that you don't have to expose all of your spending conditions, just the one you're going to use. And then another one, is there's these techniques called PayJoin and CoinJoin. PayJoin is one where it's sort of just between two people, where I'm paying you, and then we collaborate to make a transaction that has multiple inputs, 2 inputs, 2 outputs. And then what that does is it sort of obscures who's paying who and how much you're paying to who. So it just does a very small little coin join. And then there's this concept of coin join, where you have a coordinator who talks to a bunch of different wallets, and they collaborate to make a larger transaction that has lots of inputs and lots of outputs. And it's all about just obscuring the history of your Bitcoin, so that you can't easily be traced, and people can't easily kind of determine the identity of the Bitcoin holders. So that's some project ideas. And then some other project ideas, additional ones, checking the time here, would be, say I want to do a multi-sig wallet. So descriptors are amazing for multi-sig wallets, and that's why BDK uses them, because you can not only define the multi-sig quorum of keys and all that, but you can add additional things to it. You can add, like I said, time locks, hash locks. So hash lock would be basically adding like a password to spend the Bitcoin, that sort of thing. But the difficulty with multi-sig wallets is you have to coordinate all the signers. So even though BDK gives you the features that allow you to, create an unsigned multi-signature transaction, you still need to somehow get that unsigned transaction to the people who need to sign it, who need to co-sign it. So let's see something in the chat here. Okay, Albert's just saying I can go over time, so good. I'm almost wrapping up anyway. So I think, that would be a pretty cool idea. I haven't really seen it done. There's been some server-based multi-sig coordinators, but in terms of like a fully mobile-based one, there aren't a lot of options, or there's been maybe just a couple good ones created. So I think that's a wide open area. And then there's new technologies now, like maybe with Nostr, or maybe with something like SimpleX, some sort of secure communication channel to coordinate the signing of those multi-sig transactions would be pretty cool. And then another one, which is I find really underutilized, is escrow services. So this is like, so keep in mind, if you're doing a small value transaction, you're probably using Lightning. If you're using an on-chain transaction, you should be probably making a larger transaction in most cases. So say you're buying a car, or you're buying a house, or you're buying, some consulting services from somebody. Well, consulting service is not a good idea, but some big thing where, I'm signing over the title of my house or the title of my car to you. The way it's done traditional finance is you put it in an escrow. So that would be, you give it to a third-party bank account, and that third-party bank account holds your money. And then they also take the title, they verify everything's correct with the title, and then they, give the seller your money, and they give the title to the buyer. Well, that could also be done with Bitcoin in a multi-sig escrow, where the escrow agent just is one of the signing keys, and then the buyer and the seller also have signing keys. And the person making the purchase puts the Bitcoin into the escrow. And then once the escrow agent has determined that the title has is ready to be transferred to the new bot, to the new owner, they then countersign the transaction, releasing the Bitcoin to the purchaser. That kind of thing, I think, is pretty powerful, especially for very large value transactions. So yeah, pretty useful there. And then something else that a lot of people don't realize about Bitcoin is that you can make a watch-only version of a wallet. So in that example I showed earlier, I only included the public keys in the wallet description, which means no, all of the signing can be done via some sort of hardware signer or on a whole nother computer. And what's nice about that is, say you have an accountant and you've got a Bitcoin business and you want to give the accountant the entire transaction history for your Bitcoin wallet, but you don't want to give them any signing authorities. They're just your accountant. They're just keeping track of things for you. So what you could do is you could potentially, cool project would be to build some sort of plugin for QuickBooks or something like that, that would integrate with whatever accounting software you're using. And it would take the transaction histories from your watch only wallet descriptor and then just feed that into your accounting software automatically as the transactions get confirmed. Be pretty cool. And then the last one, and this has actually been, there's some little test projects that have been done, but I haven't seen a lot of uptake yet. But I think it's a nice application to say, just you want to make a simple donation server. So, and what's nice about that is you can just use like AWS or some cloud provider to host the service. It would have your public descriptor, which means it can generate new addresses for you. So every time somebody makes a donation, it can detect that the donation was made, and then it can generate a new deposit address, a new donation address for every person who requests one. But you don't need to put all your keys or any of that on your, your little AWS server, whatever you're doing. So I think that's a pretty cool, neat one that you could do with a descriptor-based watch-only wallet. So yeah, so those are some ideas. Hopefully that inspires some of you. And just a couple additional resources. The GitHub for Bitcoin Dev Kit is here. It's Bitcoin Dev Kit. And if you want to learn more about Miniscript, you can actually, sipa.be, Miniscript. That's where the guy who invented Miniscript has a really detailed technical description of how it works and all the things you can do with it. And then if you're just new to Rust and you want to learn more about Rust, this excellent free online book called at docs.rustlang.org. Recommend checking it out. It's a very powerful language. You can do a lot with it. So recommend taking a look at that too. And that's all I had. So thank you all for participating in this competition. And you can also, if you go to our website, bitcoindevkit.org, there's a link to our Discord. So feel free to jump on our Discord, and you can, all of the developers on this project are there, including myself, and we can, open this in fire. I don't know if you can see it still. Well. I guess I couldn't switch, but anyway, if you go to our bitcoindevkit.org, you can find our Discord link, and happy to answer questions there too.
Yeah, super.
Right.
Thanks so much, Steve Myers, president of the Bitcoin Foundation. Thanks for sharing all those great ideas on what we could build a Bitcoin. When you're going through those ideas, I was envisioning a fully self-sustaining and sustainable Bitcoin economy. So, by the way, everyone who's listening in on this video, we're going to leave all those links in our Discord resource channel, so you guys can have easy access, and also the Discord link to the Bitcoin Dev Kit Discord, so you guys can get help. Also, we have probably like a pretty positive announcement for everyone building here, is that we do have a $50,000 agnostic prize from Sora Ventures. So it means that it doesn't matter what technology you build with, including the Bitcoin Dev Kit. If you have something that the judges give you high scores on, you can access that $50,000 prize pool. Right now, it's two $5,000 prizes, a $10,000 prize, and a $30,000 prize. So these are really significant, especially if anyone here wants to become an entrepreneur or founder a Bitcoin startup is definitely enough money to go from an idea to pre-seed fundraising. So thank you for the Store Ventures for putting that price up. Again, guys, if you use a Bitcoin dev kit, build something great on Bitcoin, you're eligible for that prize. Super. Steve, do you have any last encouraging words for the builders out there joining the hackathon?
Yeah, thanks for participating, and also just we're very early. Like there is so many things that have not been built yet on Bitcoin, and that's why I'm really excited about Bitcoin Dev Kit, because it's gonna give everybody who uses it a little leg up to build those things, all those applications I want to see built. You know, I think will be give you a good head start in building them. So still very early.
Super, super. I'm looking forward to that too, Steve. It definitely is early stages. Come October 1st, when people turn their ideas, we'll be both of us and many other judges will be taking a look at the videos and the code to see the great projects coming out of the hackathon.
Great.
Super.
Thanks a lot. Well, good talking to you, and I'll also give you a copy of the PDF if you want to add that to one of the links.